All right. So, does anyone remember anything about last lecture? It's supposed to be over sets.
We did sets.
Sets.
We did sets.
Mostly just lists that are unordered. They don't have duplicates.
All unique, arbitrarily ordered.
Dictionaries, similar to sets, except we have key values and then the values they're associated with. So you can kind of think of it as an actual dictionary. So in a dictionary, you have a word that you can look up, and that has a description associated with it. In dictionaries, in Python, we have the same idea, except the key and the value can be whatever you want. So this is usually used for more complex data sets so that you don't need a variable for each one. So you could just have a Romeo variable that's set equal to the string green. But it's mostly, it's going to get cumbersome. So we have dictionaries where we have keys that are associated with a value. And whenever we create the dictionary, it's similar to a set in that we use the curly brackets, or braces, I guess. And each key value set is separated by a colon. All right. You usually use it for data that's grouped together. So here we have a bunch of people and phone numbers associated with those people. So each person, Sarah has her number, Bob has his number, Mary and Fred. The names are the key, and the values are the phone numbers. You can duplicate a dictionary once you've created it by using the dict keyword, same way you convert a number string to an int. You can also do this by doing contacts.copy. It's a function built into every dictionary. I don't think he shows an example of that, but okay, so how you get out a value from a dictionary is similar to how you get out the value in a list. But instead of the index of the value you want, you use the word or the key associated with it. So here we have the contacts dictionary. We use brackets, square brackets, and then the key for the value that we want to take out. So if we look at the dictionary we set up earlier, in this dictionary the key is Bob and the value is this number. So whenever we print out contacts, square bracket, Fred, did I just do Bob?
Yeah.
Same thing, same idea. We print out contacts, square brackets, Fred, it'll go and retrieve Fred's phone number. All right. Yeah, okay. So technically, dictionaries, you can use numbers for the keys. Not usually recommended. You know, lists, you can append to it, and the index of the item that you appended will be whatever number, the length of the list minus 1, because lists start at 0. Dictionaries won't do that automatically for you. You'd have to keep track of that. Usually we use it with some kind of more complex data type like a string. We can also check if a key is in the dictionary, similar to how you check if John is in a string or if John is in a list. I believe it just checks the keys, doesn't check the value. Should probably test that real quick. So I'm going to go ahead and shell and make a dictionary. Call it whatever you want. I'm going to call it test. That's easy. I'll go with red. I'll set them equal to 5. I don't feel like running a large number. All right. So if we ask Python if red in test should say true. If we ask it is if 5 in test, yeah. So it doesn't check the values, it just checks the keys. You can also do not in. You can not pretty much everything in Python. So normally, I was talking earlier how you typically get out a value in the dictionary by giving it the key. It's associated with that value. So test Fred return 5. But if I try to do one that doesn't exist, it's going to give me an error, which you probably don't want. You can instead use test.get John, and then tell it what default value you want back. So what did I do earlier? 411? So by using get, we can avoid an error by telling it what default value to use if it can't find it. So let's see. Okay, so once the value's set, right? Test Fred is 5 right now, for example. We can change it at any time. And it changes what the values in test are. So we just want a general look of test. Fred is now 6 because I set that value. It's just like how lists work, in that they are mutable, which means you can change them at will. Yeah, okay, so in this example, we have John starting out at, 457, and then we set John equal to 222, and it changes. Basic idea, yeah. You can create an empty dictionary, and then set values as you go, unlike a list. So in a list, you can only change values that already exist. So if you say, try to change index 5, and index 5, you haven't appended one to where there are 5 indexes, it's going to error. Whereas this, you could throw in as many as you want, whenever you want. So I can create John now and say he's equal to 52, just straight out of the box. I don't have to define John up here. I can set those values whenever. Okay, so most of the data sets in Python will allow you to pop, which means give me a specific one and remove it from the list. So in this example for contacts, we have, we're popping Fred out. So that'll give us the value for Fred and remove the results from the list or the dictionary. So it's useful for if you need to only have values in there until you need them out. So you don't have to, basically the easiest way of deleting values out of a dictionary. Yeah, so it also, beyond deleting it, it returns it for you, so you can save it, set a variable equal to it, store it, do whatever you want with it. It will throw an error, so you usually want to check if that key exists in the dictionary before you pop it. Yep, so you can iterate over a dictionary similar to how you can iterate over a list. It'll give you the key one at a time through the for loop. So in my little test dictionary, I've got these two values, Fred and John. So if I, for it's going to give you just the keys as each person. Most of the time, people will, to prevent confusion, because dictionaries contain keys and values, they'll do test.keys just to make it clear that it's returning just the keys. And then you could also iterate through the okay, this is sorting it before you iterate through. So you can sort dictionaries. By default, it will sort by
alphabetical.
yeah, okay, yeah, by name. Or I believe numbers come before letters, but none of these names have numbers for the first one. So I believe sorted will work with lists. So, okay, so here in this instance, we have, we're doing 4 key in sorted contacts. Contacts being the example one we had earlier. We're printing the key, and we're printing contacts, the value in context for the key. So, and that way we can easily print out each value in the dictionary one at a time just by getting the key and then getting the value for that key. Yeah, so dictionaries, every dictionary has the built-in items function, just how I did earlier, .keys. Except items will return a tuple with two values. The first one being the key and the second one being the value. So if we print person and then person 0 and person 1, that'll print the first value from the tuple, and then I'll print the second value from the tuple, and we get the key and then the value for each in my dictionary. So that's what it's doing here. You can also okay. Okay, so I believe this is talking about how other programming languages will use data records that have multiple fields in them. Dictionary is Python's way of combating that. It's a lot easier to use than what you'd have to do without a dictionary. So here's another example of a dictionary. If you like to group similar data together, so say this would be a record for a student, you'd have an ID, you'd have a name, you'd have a class, you'd have a GPA. When you get farther along, a lot of this kind of data will be stored in your own classes or objects in Python. Dictionary is a really simple way of just quickly grouping that data. So, okay. Some example code of pulling some data from a file. And returning it as a dictionary. So this specific instance, it's a dictionary of 1. So not incredibly useful, but he has an in file. He creates a blank dictionary here, and then reads the file, splits by a colon, and then sets 2 different values equal to. So essentially, this file should contain a country separated by a colon and then population. And then this is just part of the code. Okay, here's the rest of the code. As you can see, this one's called extract record. It takes in a file and it just does one read line. Here, we're calling that extract record function multiple times until we get nothing back from what it returned. So until it no longer finds country in a population. Wonder if he has that program. Okay, no, he doesn't.
Basically, anything in the PowerPoint, it's just the PowerPoint he has. I think it's from the book.
Oh, okay. In this example, we still have the record dictionary that are extract record returns, and it's just showing getting a value for the key country and for the key population. It's a more direct approach so that it's a little bit easier to understand because everything's labeled as opposed to just having a list of data without labels. Technically can be done, but you get the list of the dictionary, the number of items that are contained in it. My example would be 2, because I've got 2 people. We already went over a lot of this. Got get, pop, and values. Okay, so along with being able to iterate over the keys and the items, we can also do values. If we just want to iterate over the values that are in the dictionary. So if we print, should be 652. So if you just need to iterate over the keys, or just iterate over the values, or you want both, dictionaries can do that. All right. All right. Any questions so far? Oh. Yeah, so dictionaries can contain any type of values, not just integers and strings. You could have a dictionary that contains dictionary. I wouldn't recommend it.
You would call them nested dictionaries.
Yes, it's bad coding, technically. You have a dictionary of lists, which I think he shows later in this. You have a dictionary of objects. You can have a dictionary of files, pictures, functions. That's a little annoying, but so I believe what he's talking about here is his dictionary of lists. So a book index. So, oh, no, it's a dictionary of sets. So he's talking about indexing a book, right? So he wants to know what page or what pages each word in the book occurs on. Kind of a complex task. So it needs to include every term and the page on which the term occurs. If it occurs on the same page, then it includes the page number only once. That's usually a key that you want to use a set, because sets are, they don't have duplicates. And, you know, sets are a little faster anyways, and this is pretty complex. So, for example, the word example occurred on page 7 and page 10. The program appeared on page 7 and page 11. So you could easily do this with a dictionary. The key would be the word, and the pages that it occurred on would be a set. Could be a list. You'd have to manage the duplication yourself. There are, when it comes to programming, there are 100 different ways that you could tackle any problem. But this is the most straightforward and what they want to show us. So we have a dictionary of words, and the value for the example key is a set of numbers. I believe they'll show, it's just code. Great. All right. So why use a dictionary? Well, dictionaries, each index is unique. So even if you encounter the word example more than once, it'll just change the value, for example. It won't create a second copy of it. All right, so if you wanted to, we showed sorting by key earlier. So if you wanted to list all of the words by alphabetical order, fairly easy to do that. I believe you can sort a list set too. So the numbers appear in chronological order. And I think he shows some code. All right, so we have an empty dictionary. We read the file. We're still using extract record. I don't think. Oh, his add word function is, there it is. So it shows the extract record code from earlier, except this time it's changed slightly. So we're not calling it country and population. We're just calling it field 0 and field 1. And then we're returning a list of the page that it was on and the term. So it looks like they already found what pages each word was found on. It's just all in a file called index data. We don't have access to. So after we call extract record, we call add word and pass it 3 things: entries, term, and page, which we got term and page from the extract records function. And I believe entries is the dictionary. Okay, so oh, okay. This is where we're creating the set. So if the set doesn't already exist, we create the set and we put it in the dictionary we created. So the reason why changing entries here works, or changing the set that is in entries works here in a separate function, is because dictionaries and sets work by reference. So whenever you pass entries, the dictionary, into this function, it gets copied as just a pointer to its actual location. So any changes made to it will remain, as opposed to if you passed a number and then you changed the number, you increased it by 1, those changes wouldn't remain. But dictionaries and sets, because they're complex data types, they're passed by reference. I don't know if he's covered any of that. All right, so again, we are sorting the entries and iterating over the keys in the dictionary. So the entries is the dictionary with each word and the set of all page numbers. And we are sorting the set of numbers for each word, so that they come out as, you know, numerical order. 7 comes before 10. Oh, is he? Okay.
That's good.
Yeah.
Hammer
Oh. I thought it was going to be a presidential alert
Is it a
again.
flash flood or
Hammer.
Amber.
Yeah.
So here he's printing each page number one at a time, separated by a comma, and within set to blank, so there's no new line. So it all comes out on one line. I think the code changed because it's separated by a colon instead of a comma now. But we have the dictionary word, or not the dictionary word, the word in the index. And then,
is this just like a key value pair?
yeah, pretty much.
Okay.
It's just a key and a value.
So vanilla is the key and the value is the whatever the
So
that
in-
second colon though is,
Serial.
In this example, so the value is actually a set of numbers.
so there's not 4 or 3 different values assigned to the vanilla.
There are.
Okay.
It's a set of 3 different numbers.
So it's like key value, except you can have multiple values for each key.
You can only have one value.
But
The
not
thing
the
is,
list.
yeah, the value associated with vanilla is a set of numbers.
Oh.
So you're printing, you've got, okay, here, I got an example. All right, so we have an override test with vanilla, and its value is, that's a list, a set of okay, so the confusing thing is that the curly brackets are used to define sets as well as dictionaries.
And tuples, right?
Tuples are just parentheses.
Okay.
But the difference between when you're defining a dictionary versus a set, how Python knows is a dictionary will have colon separated values, whereas a dictionary will just have values. So the value for my vanilla is a set of numbers. So in this, if I try to get out vanilla from my list, it's going to give me the set of numbers. So you can only have one item here. It's just that because it's a set, it groups them into one item.
Okay, so those colons were just specific to that particular dictionary, the way he defined the values for the keys.
Every dictionary will be defined with a colon.
No, but I mean in his
Like in the printout on the slide.
yeah. Could
Oh,
you, instead of
yeah.
using commas, could you have used colons to separate your?
It's weird that they're printing it with colons separating each one.
It should be commas.
You see what I'm getting at?
Yeah.
Like
It's confusing that they're each colons. They should be commas, in my opinion.
and by the way, that changes from Python 2 to Python 3. I just found out.
So, well, this format, he specifically, you have to code this. You can do so this is a set of 3 numbers, right? You can use the join function. It's a part of every string. So I'm saying this string of just a comma and a space, join it with these values. So, oh, they're numbers. It wants them to be strings. Great. So, 15 for numbers.
So can you
These
cast them
strings.
within that? Can you? I mean, since it's going to duck type it, can you cast it? Can you cast the first 1, 2, 3?
I don't think you can.
Okay.
I'd have to go back and change them all.
Could you not go string test for them?
No, because
So once you have values in there, you're stuck with
yeah.
the value type. Okay.
Should be str.
Generally.
STR, not-
Right. So, oh, you're right. So it converts the actual string representation for that set, and that string representation is 1, 2, 3, 9, 8, 0. And if you noticed, I put them in a different order than they appear, because sets are unordered. I don't know why Python decided to use curly brackets for both sets and dictionaries, especially since they're teaching it in the same slideshow. Makes it really confusing, but they're both really useful. So sets are great for things that you want quickly and you don't care for duplicates.
So the way you're demonstrating this all in class is not actually the way we would ever use it in the real world. I mean, you would be reading in stuff. You wouldn't be defining your own sets, value by value. Because
Value by value, you wouldn't.
yeah,
But yeah, usually you create a set.
the information's coming from a different source is what I'm getting at.
Yeah, so
Okay.
normally you just create a set and then start adding values. And that's the typical what you'll be doing in actual programs.
Sure, as a loop or something.
Yeah,
Okay.
iterating over some kind of value. Same thing with dictionaries. You usually won't hard code either the key or the value. And because of how sets work, this could be a set of just one, which might sound weird at first because, why would you need a set if there's just one value? But consistency is key. You wouldn't want a dictionary where some of the values are sets and some of the values are integers, because then if you suddenly try to sort an integer because you're expecting a set, you're gonna run into an error. Or if you try to do math on a set, you're gonna run into an error. So most of the time, we'll just define what something will be. I'll say this is a set, and then start filling it with values from a text file or a database or user input. In this case, it's a text file. And the nice thing about it is that even though vanilla has 3 different statistics, there's only one vanilla. That's why it's a key. There can only be one of them.
So the dictionary is just extending the object set, right? So if the set is an object, the dictionary is just an extension of. I mean,
Yeah.
all it's doing is extending that class.
So you have names for each
Almost
one.
a subset of. I mean, the vernacular is confusing in this case, but I mean,
Yeah.
As a Venn diagram, a dictionary is kind of a specific set then. A specific kind of set.
Yeah. So you could do like a set of tuples or something and have a very similar kind of output. But because of how Python does dictionaries, so that the keys are hashed. I don't know if you know what hashes are. It's where you do like a little mathematical computation to get a unique value just for an input. Those are hashed, so Python can look them up incredibly quickly and uniquely. That's why test with a capital vanilla here would be different from test with a lowercase vanilla, for V for vanilla.
That's case sensitive.
It's case sensitive because
The
it's
hash values are different then.
very,
that
very
makes sense.
specific, and it's very efficient. It doesn't, in my experience, it doesn't matter how big your values are. You could have 100 and it would still take roughly the same amount of time as it would take to look one up if you had just 10.
Because they're taking the data and then encoding it down to the same string of hash.
It's mostly just a hash, and then it points to where the real data is located.
In a dictionary, can you have duplicates for the keys?
Yes, you can have as many duplicates, like different keys can have, they could all have the same value, which is common if you want to have default values. So like you set them all to none at first. It doesn't care. Oh, okay. Okay, this is the text file that they're looking at. This is the text file for the flavors. So it wants you to process this so that it looks something like this. Looks like we read in each flavor, combine the numbers for each flavor, and also combine each column. If you had a simple list, it wouldn't be ideal. You could have a list where the first value is chocolate, second value is this number, third is that, fourth is that number. But that would get cumbersome, and you wouldn't be able to sort it by flavor easily. Here,
So this is a stack sort, then, is what it's doing. So in the first one it comes to.
Yep.
Okay.
so essentially, what to take out of it is a dictionary is similar to a real dictionary, where if you want to look up what the word, what a specific word such as ice cream means, then you go to the dictionary, you find that key, and then it gives you the definition. Except in this, the key can be whatever you want, and the value can be whatever you want for each key, even if that value is a set of values.
Just like in a real dictionary where you could have multiple definitions for a word.
Yeah.
Okay.
Or such if the word has a verb version versus a noun version, but they'd all be grouped under what the result for that value or that key is.
So pardon my French, but the word fuck could be classified as an adverb, an adjective, a noun, whatever. Okay.
This is just doing the ice cream text file, read it in, split by colons, because each number was separated by colon for some reason. A lot of times these will be comma separated because Excel likes comma separated value charts. You can save an Excel spreadsheet as a CSV, which just has each column separated by comma, which is really nice for programming because you can read it as a text file versus an actual Excel spreadsheet, which are kind of a lot of work to read.
So I'm curious. Go back 2 slides.
Mhm.
See how all of the values are the 0 position or whatever?
Mhm.
If you're going, is there a way to, like, say each of those has their own set values? Is there a way to print just all of the zeros or just all of the ones?
Yeah, so
That way,
have-
like, if you only want to know the first value of each, like, say we're doing another assignment, and you've already made your dictionary, you've already made what your vanilla and your values equal, but the information he wants is everything in the first position. Print it out.
You'd you'd iterate through your dictionary, and it looks like it matters. Let's look at this. It matters the order of these numbers because it looks to me like of different ice cream flavors in multiple stores. It looks to me like each value tells you the sales for different stores. So you'd want to keep 8580 in the first spot. So you wouldn't want to use a set because sets, they aren't ordered, so their numbers will flip around all the time. But so you probably want to put this in a list to keep the order. Hence why this has 0. You want the first one for Rocky Road. So you'd iterate through your dictionary, and for each value, just get the first one. Just get bracket 0.
So this may be jumping ahead, but could you make it multidimensional so that instead of doing the flavors of ice cream over in the key, you put the stores, the particular stores over in the key, and then in the value have a multidimensional
Flavors
set
for
of
each one.
values where the flavors are then under the, you see
Yep.
what I'm getting at, like multidimensional array.
Definitely could.
Okay.
You can store any kind of data type in it. Doesn't care. There might be certain special data types where you couldn't, but they're not certainly not included with Python.
Not the primitives.
Yeah.
Okay.
Not even the object ones, the non-primitives. So here we're reading that flavors text file we were looking at earlier, splitting it by colon. That split returns a list. So our flavor will be the first value because in the text file it was flavor colon number. So flavor is the first in that list of split. And then the others we're getting from our function build list, which is here. So build list takes a list called field, iterates through it, and starting at 1, because we skipping the first one, 0, because that one's flavor. We already got that. And then pulling that out and appending it to a new list. That's a lot of work for what you could do with just slicing. But this is just their special way of getting 1 through 3, or 1 through 4. No, it's 1 through 3. The others, not the flavor. So the floats we had after the flavor. And then the okay. Oh, I think he's calling this earlier. Yeah, he's calling it main. So print report, we're passing it the dictionary we had, I think. Yeah. We're iterating through the values, just the values. So this dictionary's got values. Checking if length of store sales greater than number of stores. Okay, so this is just finding out how many stores there are. It's not a great way of doing it. So if the number of stores we have, start to 0, is less than the number of stores for each flavor.
What is that first one doing? I define the number of stores as the length of the longest store sales list.
So each flavor has a list of numbers, right?
Oh, okay.
Yeah.
And the longest one of those will be stored as number of stores.
The longest, the store that sells the most number of different kinds of ice cream, or the store that sells the most amount of
Or, no,
It's
not,
going off of like, if there's
it's going
five
off
the
of-
floated numbers, that means there's 5 stores.
It's going off of this
okay.
each store is put in vanilla. So this one's got 3 different stores. This one's got 3 different stores, 3 stores, 3 stores. They've all got 3 stores. But it could be possible where one of these has 4 for some reason. Here, you have a strawberry stand.
And so that function is to ensure that if you did it the other way, that data would get cut off. It wouldn't be shown, because if you created it with a store that only has 3, then listing the last one would get the last value cut off or something.
Actually, the reason it's doing it is to prevent an error. So here we're creating an empty list, or not empty really, a list of zeros
Mhm.
times the number of stores. So if there are 4 stores, then a list of 4 zeros. That's just an easy way of creating an empty list or a list with default values. So that's so that if you're trying to set the value for a store, you don't end up trying to access an index that doesn't exist and crashing the program. A blank slide. All right. This is just continuation of that. Okay, so for flavor, so flavor is the key, and iterating over a dictionary, if you don't specify .items or .values, will just give you the key. So flavor would be the key, and we are pulling out the list of sales for that flavor, and then iterating over our number of stores and calculating flavor totals, setting the sales for that store, and setting the totals for that store. And printing out the sales for that flavor. It's not printing out flavor though. Oh yeah, there it is.
Okay, there's one.
Then we get to the end and we print all of the store totals.
Oh, is that a nested for them?
Yeah, so the for loop's cut off on 2 different pages. That's the beginning.
Okay.
And if you notice, this is tabbed over. So yeah, this is a 4 instead of a 4. Because each flavor has multiple stores, multiple store values.
Yeah, I thought it was just going through one flavor.
When you get into nested data types, you tend to have nested loops as well for each value inside of that data set. All right. Modules. You guys gone over modules yet?
We should probably pick that up, but I mean, modules for the next class, maybe.
Yeah,
Instead of
we
starting
got
at-
15 minutes left.
Yeah. Oh. I think this is kind of short.
Yeah, I like to.
Yeah. All right. So modules are where you put your functions in a separate Pi file, and you import that file into your main program. So usually that second file won't have any actual code that's run outside of a function. So I'll have a bunch of functions, classes maybe, but no code outside of that. Because usually you can have a ton of functions in your program. If it gets massive, you want to stick those in a second file. Because once you know that a function works, you put it off to the side, and then you don't have to worry about having to see it. You just call the function, and it works.
And then if you make you're making a program, but you want to separate the functions that you've made in that specific Pi file, you want to separate them. into
Or,
different files.
If you created a function that does some cool mathematical thing that either a project team member needs access to or a friend, you put that in a module and you send it to them, and they import your program, and then they run your function from that module.
So what's the syntax if it's in the same directory?
If it's in the same directory, you just import it. It's import and the name. You leave off the .py.
And then you can just call the function.
It's you don't call it directly. You say whatever the name of it was, dot, and then the function. Usually you don't want to have any code inside of the module because whenever you import it, it will run everything that's in it. So you only want functions in it usually. And I believe Python's definition of a module is a Python file without any code that'll run by itself, aka all modules.
So don't call your
all
functions
classes.
in your module.
You can call it in the module, but so Python has a way of saying only run if this is the main file being run. So like you call it directly, you say from idle or something. It's if name equals main. That says if this is the main module,
Oh, nice.
aka if this is the one directly being run, then maybe I want to call my main function or something.
That would be your module's main function, right?
Yeah, you don't have to call it main. A lot of people call it main. That name's not set in stone. It's just leftovers from other programming languages usually call their main program main. Usually you'll have a driver module and then supplemental modules. So your main Python program and then your tools that you put in a second file that you call. Yeah, they're calling theirs main, just usually good programming practice. You can call it whatever you want. As all functions you can call. Just call it something that makes sense. Don't call it John, unless if it has to do with something called John.
Import Java.
Import John.
Yeah.
Don't call it module 1, for instance.
Usually you want to separate these into things that do similar functions. So tabular data, sales report, or no, I guess those are the only two.
So
But usually you'll stick functions that have to do with sales reports in a sales report module. It just makes more sense that way.
So like math calculations in a
Yeah.
single module.
You wouldn't want to put like some game in there. You want to leave your math calculations in that module and just that module. What you're saying earlier, if the function's called, or if the Python file is called tabulardata.py, you import tabular data, and then you do tabular data.print report. You can do from tabular data import print report, and then at that point you could leave out the tabular data dot.
Just makes it faster if it's huge.
Yeah, but some modules will conflict. Say you import two things and both of them have a print report, it's going to use the second one that you import.
Sure.
So usually you want to leave it like this, like this. It takes a little bit more time typing it out, but a lot of
IDs.
idle won't do it for you, but a lot of them will. Once you type this out and you hit dot, it'll give you all the functions in that module. Idle doesn't do it. It kind of does sometimes.
Sublime does it. Atom does it. There's a bunch of free ones.
VS Code, even whatever the PyCharm, I think.
Yeah,
they're using
PyCharm
here.
did it.
Yeah. All right, I think that's it. Just talking about sets again. I think it was a review. Any questions about sets or dictionaries or complex data structures? 137. I think a couple of people came in late. Do you want attendance?
Yeah, Robert Caldemall and Shane Hughes.
Sorry, what?
Robert Caldemall and Shane Hughes. Boom.
All right. Any questions? Think we're good? Did it make sense?
Yeah.
A lot of people use dictionaries. Dictionaries are nice. Sets less often, usually for if you do something complex with like statistics or something. But dictionaries are super cut and dry.
I do have one question. Do dictionaries have to have sets, or can you use lists?
You can use lists, you can, or like I did up here, a dictionary of just ints. It doesn't matter what data type goes here. This is the value. So instead of 5, it could be a list or a set or another dictionary if you wanted, or a random number or a
The reason I
picture.
said that is like sets are random, whereas lists are alphanumerical.
Yeah.
So if I did a dictionary but had lists in there instead of sets, that way it'll stay consistently in order.
Yeah.
That's possible.
I think in this example, it's using a list instead of a set for each one. So Rocky Road is equal, the value for the key Rocky Road is a list of these numbers.
Mm.
The first one being number 0, 1, 2. So it can be whatever you want. Python's really great about working with objects. I don't think it comes with Python, but the images module is fantastic in a dictionary because they're so big that it's much quicker to access them like that. You put like whatever their ID is in the key, and then the picture itself in the value. So even for the keys, they don't have to be strings. They could be ints. It could be any data type, simplistic or complex. All right, that's it.
Don't forget to stop the recording.
Oh,
Yeah.
Podcast.